Hi, my name is George Lemke, and for my Do Something and Report It project, I chose to build a solar USB charger. Before I get started, I'd like to share how my project will affect the United States energy usage. There are about 292.8 million cell phones in use in the United States right now, as reported by the CTIA. I tested three cell phones, and to get from 0 to 100%, it took on average zero point zero 0.06 kilowatt hours. My phone battery lasts about 2 days, so those are the numbers I'm going to be using for my calculations. If these numbers are true, 3.2 billion kilowatt hours is used per year to charge cell phones in the United States. And that is enough energy to power New York City for almost 6 hours. On the university-wide scale, the University of Minnesota reports that we have 35,433 students attending as undergraduate students, and most or all of these students have cell phones. And if this is true, 388,000 kilowatt hours are used by university students to charge their cell phones every year. My personal usage would be about 10.95 kilowatts per year. However, when testing my cell phone, I left it plugged in all night one night and used the kilowatt reader to read how much energy it used, and it used 0.12 kilowatt hours, almost double my average. So depending on how much you charge it, and if you choose to leave it plugged in for more than getting to 100% charge, the energy used will increase. Why I chose to build a solar charger: first, it would cut down a large energy use from charging my USB devices. It can build something I can use every day, and it helps save money by lowering my energy bill. The materials you need for this project are a solar charging panel, a USB circuit, a battery holder, a diode, a lithium-ion battery, some wires, and I chose to contain my charger in a tackle box. Some of the tools I used were a soldering iron, a wire strippers with a wire cutter attached, and double-sided tape to hold down my components in my tackle box. First, you need to connect one end of the diode to the positive side of your solar panel. Then connect a wire to the negative end of the solar panel and connect another wire to the other end of the diode, then you solder it onto the panel. Next, you can run those two wires and connect them respectively to their positive and negative sides on your USB circuit. I chose to include a lithium-ion battery pack in my charger so I could charge the battery pack, and then at night I could still use my charger to charge my phone, since this is when I charge my phone the most often. To do this, I attached the positive and negative ends of the battery pack onto the same wires as I'd used to connect to the solar panel, and those wires were attached to the USB charging circuit. Here you can see my finished product contained in this tackle box. You can see all the electrical components are inside, and the solar panel is attached on the top. Here's a short video about my project. Here's my completed solar charger. You can see I attached the solar panel to the top of a tackle box. And then inside, you can see we have all the electrical components. We have the battery case and the USB circuit board all attached to the back of the solar panel. I have my phone plugged in right now. We're going to expose it to the sun, and you'll be able to see that it is charging. Improvements I'd like to make my charger: I'd like to make it faster charging. It takes about 3 times longer than my fast charger does for my phone. A larger battery capacity would be nice, so I could charge my phone more than once. And more power to power more devices. My solar charger did not comply with my computer. In summary, this cuts my energy usage by 10.95 kilowatt hours, but it could drastically affect national usage if everyone chose to use solar chargers. And here are some of the sources I used for my project. Thank you for viewing.